Okay, so today we will continue with section 1.3 models and applications. So what is models? Models is for a lot of real world problems we wanted to turn into a math problem. What happens? We wanted to model all these things, what is going on, like models for the stock market, models for to predict when a patient will recover, models in chemistry, models in biology, so many, almost everything you can use a model. And sometimes it involves math only, but most of the time it also involves math with another subject. Okay, and a typical thing for these model questions is the question is also called the word problems, which all the students really hate. But actually, these word problems are typically easier than the calculation questions in the mathematics. Okay, so today we will talk about the strategies for solving this word problem. So the first one is let x represent one of the unknowns. Okay. Oh my god, my writing is good. Or any other variables that you like. You do not need to use x. So the next step is very important. So you have to write an equation in x that model the problem, because if you wanted to find the unknown, you have to set up an equation. Okay, you have to have the equal side. Okay, and then you solve for the x. The most beautiful thing about the word problems, you have to check the answers. Like if you set up an equation with time t, but when you get your answer, you get t equal to -2. Could we have negative time? Maybe not. And if you set the length to be x, and you get the x to be -5 centimeters, could we have negative length? No. Okay, so you can, for these questions, you have to check your answer in the original wording of the problem, means in the context of the problem, not only for the math part. Okay, so now let's look at some examples. So the first example, when a number is decreased by 40% of itself, the result is 72. What is the number? So what is your first step? Let the number be x. Then we wanted to write up an equation in form of x. Yeah. So let's look at this question. When a number means x is decreased. What means decrease? Minus, yeah, 40%. 40% is 0.4. Of means multiplication. Itself means, what itself? It is x. The result is, what means is? Means equal 72. Yeah, so this is the equation. Then what will we have? X minus 0.4x, combine like term. X, what is the coefficient for x here? It's actually 1, yeah. So 1 minus 0.4 is 0.6x, equal to what? 72. Here is what? Multiply. What should you do when you get rid of multiplication? You divide, yeah. So x is what? 120. Okay, so you can check 120 minus 0.4, so it's okay. You can check. Okay. So the other one number exceeds another by 2. The sum of the numbers is 60. what are the numbers? So what is your first step? Let x be the number. Okay, so one number exceeds another by 2. What will be then the other number? Exceeds, it means more, it's bigger than the other one, yeah? So the other one should be smaller, so it will be what? X minus 2. Yeah? So the next sentence is the sum of the numbers is 60. So x being one number, the other one is x minus 2. So the sum means x plus x minus 2 is what? 60. Combine like term, 2x minus 2 is 60. 2x is 62, x is what? 31. What will be the other one? 31 minus 2 is what? 29. So what will be your answer? 31, comma 29. Okay, so the next example. Okay, so after 80% of reduction, you purchase a new dryer on sale for 144. What was the original price? Let the original price be x, yeah? I know. Okay, so what should we do? So you purchase a dryer, so original, what will be the relationship? Original minus the reduction equal to the price, yeah? So what do you spend finally? 144. What is the original? X. How much is the reduction? 80% is 0.8, yeah? Am I right? No. Think about this. You only have a sale, $0.8, you will be happy? No. This is 80% reduction of what? 80% of reduction of its own price. So it's 0.8% times what? X. Very important. Okay, so it's like 80% of its original price. Okay, that's very important. So similarly, what is the coefficient of x here? Is 1, yeah? So 1 minus 0.8 is what? 0.2x equal to what? 144. Then you divide is what? 720. You can check. Okay, very important. Do not forget the x. Okay. The next question is a typical, challenging question. Okay. So including a 6% tax, a inn charges 184.44 per night. Find the inn's cost before tax. What should we do? Let the inn's cost before tax be x. Yeah. Okay, so what will be the cost? So you can take out a receipt. Is before tax plus tax equal to what? After tax. Yeah. So what will be before tax? X. What will be the after tax? That is how much you pay, yeah? 184.44. How much is the tax? 6%. That 0.6 or 0.06. Be careful, it's 0.06. Am I right? No, because the tax also depending on the price. When you go to Walmart, you buy something $100, you pay tax, and you buy something 1,000, where you pay the same amount of tax. No, so the tax depends on the price. It's the 0.06 times the x here. You with me? So it's 6% tax is of the original price. That's very important. So it's here it's 1.06x equal to 184.44 when you do the division. Okay, so let me find a calculator. 184.44 divided 1.06 is 174. I have to check. Okay, so then these are the two other questions in this chapter. So solve for t. How could we solve for t? You treat all these things as what? Ugly numbers. You wanted only t on one side, yeah? How could you move the f? Subtract. Here, t and f are, these are what? Multiplication. How could you get rid of multiplication? Divide, yeah? So what happens? T equal to b minus f divided by fr. Okay, so the next question, you want to solve for s, yeah? So you wanted this by itself. How could you get rid of 1 over 4? Multiply 4, yeah? So you have 4c equal to f s plus k. How could you get rid of the f? Divide f divided by f. 4c divided f equal to s plus k. How could you get rid of the k? Subtract k, subtract k. So your s equal to 4c over f minus k. Okay, so this is this section.